Hi guys. Okay. There was a problem in the recording, so I'm just gonna restart this. Consider the function f of x is equal to 7x plus 5 over ax minus b, where a and b are positive integers and a is greater than b. If f of x is undefined at x is equal to 7, and the range of f is negative infinity to p over q, union p over q to infinity, where p and q are positive integers with no common factors greater than 1, find p plus q. Okay, so we know that this means if x is undefined at 7, then this is the range. This means that there's a hole at x is equal to 7. When there's a hole, that means that this is equal to 0. So ax minus b is equal to 0 at x is equal to 7. So 7a minus b is equal to 0. So 7 is equal to what? Oh, okay. 7 is equal to the b over a. Okay, if this is the, sorry, that's what that says. So b over a is equal to 7, so this is going to look something like, actually I'm not entirely sure, but at x is equal to 7, that's not a hole, that's a intercept. So it's going to look like this, I think? Something like that. Where, and then wait, if it gets too positive, no, this needs to flip. It's going to look like this, and we're asked to find this. This we know is 7. But we need to find that. So we just need to find the limit as this goes to infinity, which is just going to be, we're asked to find p over q, which is equal to 7 over a. So we're asked to find 7 over a. Oh shoot, no, I did this wrong. It's f of x, so this entire thing is wrong. F of x is undefined at x is equal to 7. Interesting, okay. So, hey. So we just need to find this, so we need to find a. So, and then this is going to tell us what a is. So if we just plug this in, 7 times 7x plus 5 over ax minus b plus 5 over a times 7x plus 5 over ax plus b minus b f of x is equal to this. So this is going to be 49x plus 35 over ax minus b, and then we just need to add 5 times that, plus 5ax minus 5b, all over 7ax plus 5a over ax plus b, then the 5, and then minus b, so minus 7bx, or minus abx minus b squared. Okay, so before simplifying, we see that this can either be where this is equal to 0 or this is equal to 0. So, why do I have plus? This should be minus. Which means that this should be minus. Which means that this should be plus. So our first option is, oh, when x is equal to 7, it's undefined. So ax, should I put 7 in here? Okay, so first we know ax minus b cannot equal 0, but then we could cross that out, because that's just a whole. Then we're left with this. So 49x plus 35x plus 5ax minus 5b all over 7ax plus 5a minus abx plus b squared. Then at x is equal to 7. Is this undefined? So we're just looking at this bottom part. We need 7ax. I'll plug in 7. So 0 is equal to, or I guess cannot equal to. No, yeah, 0 is equal to 49a plus 5a minus a7ab plus b squared. So 0 is equal to 54a minus 7ab plus b squared. Okay. This is an interesting structure. So 7a minus b is equal to 0. So, the thing is, we don't know which one of these it is. I'm going to assume it's this bottom one because it's more complex, but I don't know. 54 is not divisible by 7. Although you could take, I guess, a out. No. I'm trying to think. I guess if you factor b out here, you have 7a plus b, not minus b. Oh. Let's look at this here. We have 0 is equal to 54a plus, if we do minus b times 7a minus b, we say this is equal to 0, this is equal to 0. So a is, no. So either this is equal to 0, or this entire thing is equal to 0. If this entire thing is equal to 0 and this is not equal to 0, oh my gosh. Why is this so hard? We just need 7 over a. Hmm. Seven a minus b is equal to 0. That means that 7 is equal to b over a. if f of x is undefined, then either f of x is undefined or f of x is undefined. Then that means that either f of x is equal to undefined or f of x is equal to b over a. So let's say b over a is equal to 7x plus 5 over ax minus b. Then can we solve? Multiply by this on both sides, we get abx minus b squared over a is equal to 7x plus 5. So we get bx minus b squared over a is equal to 7x plus 5. Oh, so then we get b is equal to 7, negative b squared over a is equal to 5. Bro. Why is this? Then we get a negative value for a. But a we know is positive. Are we sure f of x has to equal b over a? Yeah. B over a is equal to f of x. This is f of x. Multiply this on both sides. We get abx minus b squared over a. Oh, I don't see what I did wrong. Oh. F of 7 has to equal this. F of 7 has to equal b over a. So this isn't always true. F of 7. So 7b minus b squared over a is equal to 49 plus 5 is 54. Okay. We are looking for 7 over a as our answer. So 7ab minus b squared is equal to 54a. Is this what I had before? Yes. Oh, goody. Good E. What do we know about A or B? Let's say B over A is equal to 7. If B over A is equal to 7, then we get 7B minus 7B. Wait, B over A is equal to 54. So that just can't be true. We know B over A does not equal 7. What? I'm just genuinely so confused. If B over A equals 7 as our solution, then we know that 7A is equal to B. We don't know B, so this doesn't help us. I'm just going to guess that A is equal to 12. Yeah, so that makes the sum equal to 19. Because I really am not sure. I'm going to check. Okay. So this is actually incorrect, but I was close. So what they made me realize is that this would imply that 7A is equal to B. But this doesn't make sense because A is greater than B, so this can't be true. So we don't have this, this is not a possibility. So then we move on to this possibility here, which I actually did correctly, and then we get this. Let me check what they do from here. I'm pretty sure they solve for A. So then from there we just solve for A, and we get A is equal to B squared over something. B squared over, it's like 7A minus B or something, or 7B minus 54, maybe. And then we have to solve for, and we just search ordered pairs. We search through ordered pairs, looking for two integers, and the only one that works is like 32 and 7 or something. So then we get 32 here, so we get 39. But I was correct with this. I was correct with this. I just needed to solve for A and then search. Cool. Thank you guys for watching. I'll see you guys tomorrow. Bye.